such as anything within the 192.168 .x.y address range cannot be visible on the internet. Okay, basically it is a restriction. The same thing applies to 10.0. Okay, if you have a network address that starts with 10.0. something, that's also considered a private IP address, which means no computer on the internet should have that address. So that's kind of weird, because then what is it going to be useful for? And how can my computer with 192.168.1.2, how come that computer can actually go onto the internet when the IP address is saying that it cannot be visible from the internet? That's the question. But before we answer that question, are there any questions about the stuff that we have talked about so far, which is mostly related to the area code, your network address, and the number within the area code, which is the node address. The whole thing is the IP address. So is that analogy working okay? Okay, very good. Okay, so this is where the analogy of using phone numbers will start not to work anymore, because all the phone numbers can call any other phone number. But in this case, we have phone numbers that cannot basically call out to other phone numbers. You have to rely on someone to relay the messages. Okay. So now we are moving on to how come we can have computers in one LAN connect to the internet using just one ISP subscription. Okay, that's the question. And this stuff here will help answer that question. Okay. Let's think about this particular problem here. So let's just say that we have Tom, Dick, and Harry in an apartment. Okay, they're renting one apartment, and one guy decides one day and say, I think we need internet connection. Okay, let's say Tom said, we need internet connection. Dick and Harry said, sure, that sounds good. We can do our homework, using the internet connection. So initially they contacted, AT&T and say, okay, we want to be online, so tell us how much we have to pay, ship us, the equipment that we need, and we'll hook it up. So they hook it up, and at that point they don't have any routers, so only Tom's computer can go onto the internet. Okay, so Tom is all happy in his room, being able to surf the web and whatnot. Dick and Harry are not so happy because they have their own computers, but they can't get onto the internet. Okay, is that okay so far? So Dick and Harry decided one day and say, well, you know what, Tom, we want to get onto the internet as well. Okay, and the three students, being very frugal, decided, but we don't want to pay any money to buy a router or something like that. They go to Fry's and say, $30 is too much money. I would much rather spend $30 on maybe 8 Starbucks coffees instead. Okay, well, people have priorities. I cannot say anything about how other people should prioritize their spending, but they decided to spend their money on coffees rather than a router. Okay, so what do they have to do? I'll just draw a picture here. So this is not going to be captured in the notes because I can't really draw that easily inside an HTML document. So here is the internet with all the goodies on this side, like YouTube and whatnot. And here is the AT&T box, AT&T, this is called a DSL modem. Okay, a DSL modem is a fairly dumb device. All it does is to translate the electronic signal from here into zeros and ones on the other side. Okay, so the zeros and ones connect to whose computer? Tom's computer. Okay, so Tom's computer is here, and Tom can definitely go out onto the internet, surf the web, and whatnot. Okay, now in this particular setup, Tom's computer is not going to have a 192.168.0 something address. Tom's computer is going to have an address that can be seen from the internet. Okay? Are you guys okay with that? Because Tom's computer is directly hooked up to the internet. The modem is only a translation device. It does not change the IP address. All it does is to change the type of signal to the computer, to the way that the computer can understand. Okay, so in this case, Tom's computer on the internet may be 66.205.78.10. Okay, I don't care. This is an internet visible address. Okay. So here comes Dick and Harry. So Dick is here, and Harry is here. Okay, this is their computers. Well, one way to share the internet connection is to unplug it here, plug it in here, unplug it here, plug it in here, and before long the plugs will all be worn out. Okay, and these guys will have to change, switch, desolder the connector and whatnot. So that's not a very permanent solution, is it? Okay, so they look online and say, what is the cheapest way to do this? What is the cheapest way for Tom, for the same internet connection to be shared within the same apartment? Okay, so they looked online and go, okay, how much do we have to pay to buy this? Oh, routers too expensive. Wi-Fi routers even more expensive. No. Yep, go ahead.
I know some computers have Bluetooth links that you can do that with.
Yep, you can use Bluetooth. But these guys decided that since Tom's computer has 2 network ports, okay, now this is becoming interesting because Tom's computer is a higher end computer. Most higher end computers have 2 network connectors. Okay, not 1. So Tom's computer turns out to have 2 network connectors, and these 3 guys decided to share, a local area network on this side using Tom's spare network connector. Okay, are we okay so far? Can anyone tell how many network connectors I have on this computer? Only 1. No, this one only has 1 network connectors. Huh?
That's kind of weird.
Yeah, it's not a whole lot. Our older gateways actually used to have 2 network connectors. And if you look up motherboards, if anyone likes to put your own computer together, and you look up motherboards, anything that's more than say $100, $120 or above will have at least 2 ports, 2 network ports. Okay, so Tom just turns out to have a higher end computer with 2 network ports. Okay, and Dick's computer is a netbook, and Harry's computer is also a older computer, less expensive computer. So they only have 1 port. Okay, they don't need to have 2 ports anymore. Okay, so in this particular way, Tom's computer is acting like a bridge. Okay, so Tom's computer is acting like a bridge to bridge the internet connection to the rest of the apartment. Okay, are we okay so far? Yep.
If he had 2 network ports, one was connected to the internet and one was connected to Dick's computer, right?
Mm-hmm.
Then how would it get to Harry's computer?
This part, I would leave it up to you guys to read up in the book, because this is a networking topology thing. In the good old days, when people used 10 base T connectors, this can actually be done. This is called a multi-drop connection. In other words, physically, the wire actually connects from Tom's computer to Dick's computer to Harry's computers. A bunch of wires are connected like that.
Are we talking about Ethernet cables?
Yeah.
So just physically though, the Ethernet cable coming from Tom's, does it split? Like I'm wondering.
These are the older ones.
Hardware.
Yeah, these are the older coaxial cables.
Okay.
The older. In the back in the good old days, networking cables are not Cat5. They're not like the phone plug. They are coaxial.
Right.
The coaxial cables have T joints.
Okay.
So Dick's computer will need a T joint here.
I see what you're saying. Okay.
Yep. So physically, they're the same conductors connecting Tom, Dick's, and Harry's computers all together. And today we don't have that technology anymore. We don't use that older technology. So today we use Cat5 cables, but Cat5 cables are not designed to be split and connected to multiple things at the same time. So in today's technology, we have to put a hub or a switch here. A hub or a switch is really inexpensive. If you go online or buy used, you can probably pick one up for $2-4 or something like that. I mean, they're not expensive at all. I was able to buy a brand new one for $10. Okay, because they're really dumb devices. They don't really do a whole lot. Okay, so we will just, but in terms of logical connection, it is as if these three computers are all connected together using just solders and just soldering the wires together. Okay, all right. Now, Tom's computer has a little bit of a problem because it can talk to the internet, identifying itself as 66.205.78.10. But it also needs to somehow talk to Dick's computer. Dick's computer cannot use this address, can it? Because only one computer can have one internet exposed address at any particular time. It's just like with a phone number. Can two phones have the same phone number that is reachable by the phone network? That would be pretty bad, right? If you dial out that number, who are you going to get to? Well, sometimes this person and sometimes the other person, right?
Well, technically with Google Voice it could be done.
It's called a multicast, right? There's such a thing called multicast addresses in networking, and the purpose of a multicast address is so that you can do that with great efficiency. But if we are not talking about multicasting and just regular transmission, I cannot use this address with Dick's computers or Harry's computer. Okay, so in this case, Dick's computer is going to have the address of 192.168.0.1. We'll pick a 2 here. And this one would be 192.168.0.3. And Tom's computer, now here comes the fun part. Remember what I talked about, the network address? The network address for Dick's computer and Harry's computer are 192.168.0. Yes? And remember what I talked about? All computers of the same local area network must have the same network address. So that means Tom's computer, in order to talk to Dick's computer and Harry's computer, also need to have the same network address. So that means with this interface here, the network address has to be 192.168.0, and we'll just pick one here, but it can be any number up to 254. Okay? I look at this picture here and I go, is that a problem? Because Harry's computer and Dick's computers are not a problem because they have one single IP address. They are a private address, but since they're sitting behind Tom's computer, they won't be visible to the internet directly, so that's fine. But I look at Tom's computer and I go like, it doesn't look right, because it is one single computer, but it seems like it has two addresses now. Okay, it has the 66.205.78.10 address, and it also has the 192.168.0.1 address. Is that a problem? It is actually not a problem. Okay, it is not a problem because it is not the rule is not a computer can only have one address. It is a NIC can only have one address. Okay, that's why I put computers in quotes earlier. Okay, all computers within the same LAN must have the addresses that start with the same bit pattern. But as it turns out, the rule is each interface. Okay, and if you want to translate interface to a word that we know, it is NIC, which stands for network interface.
Network interface card.
Interface card, right? Is each interface can only have one IP address. So this means if I have a computer that has 10, NICs or 10 network interface cards, guess what? It can have 10 different IP addresses. Okay, is that okay so far? Because this is now changing the picture quite a bit. Because Tom's computer now has two addresses, which is actually what it needs in order to accomplish what it needs to do. Okay, because it needs one address, 66.205.78.10, to talk to the internet, to talk to other computers. But it needs a different address on the